we're going to be solving logarithmic equations using what we call exponentiation, right? Exponentiation, yeah. Wow, that was pretty good, Mr. D. Okay, so the first thing we have to do with these equations, which means we have what? Equal sign, right? We have to make sure that the log term is isolated before we exponentiate it. Okay, so looking at the first example here, I have log base 7 of 4x minus 1 equals log base 7 of 2x plus 5. Now notice that these terms, these numbers are in parentheses, so they're quantities, right? So we do, in fact, have the log terms isolated on both sides. So what we're going to do is we're going to we have to get rid of those log base 7s, right? So we're going to use this exponentiate rule to get rid of those logs. So I'm going to make it an exponent of its base. See how I'm like put a 7 there? So now this became my exponent. So what's going to happen is, and we learned this, right? This, because it's now an exponent, the bases are the same, so they cancel out, right? Isn't that cool? That's called exponentiate. So I end up with 4x minus 1 equals 2x plus 5. And you guys could probably do this in your heads by now, right? Let's see, I'm going to subtract 2x from both sides. So you have 2x minus 1 equals 5. I'm going to add 1. Add 1. So 2x equals 6. And divide by 2. And what do we get for x?
3.
That's right, 3. That's my answer. Easy peasy, right? Okay, next, any questions? Next one, we have to isolate my log term, right? So I'm going to subtract 2 from both sides first. I got to get rid of that 2. So I'm left with log of x minus 9 equals 5 minus 2, 3. Now, what am I going to use for the base for the exponentiation? What's the base of my log? 10. Good, Eddie. Okay, remember, if there's nothing there, it's the common log 10, so I need to use 10 to exponentiate. So these cancel, right? So I get my x minus 9. And what's 10 cubed? 1,000. Good. And now I just got to solve for x. Add 9 to both sides. My answer? 1,009. Bet you never had an answer like that in algebra before. Okay, first thing I have to do is isolate the log. In this case, I have the natural log of x. So I'm going to, let's see, I'm going to add 2 first to both sides. I get 7 times the ln of x equal 21. How do I get rid of the 7? It's multiplication, so I have to divide by 7. And I get the ln of x equal 21 divided by 7, 3. Now the new point for this section, exponentiate, what am I going to use for the base? What's the base for the natural log? Huh? I heard it. Thought I heard it. E. So I'm going to exponentiate using E. So my E cancels out the ln of E. So I have x equals E cubed. And this is where your handy dandy calculator is going to come into play, right? So I do the second natural log key. So second natural log gives me e to the 3 and enter. So x equals 20.09. Questions, comments, concerns? There's something what we got to talk about, and that is extraneous solutions. Okay, if you guys remember the parent function for the log function, common log of x, right? Remember. It goes through the turning point is 1 comma 0. So it comes from the bottom, turns, goes like that. Do you remember? Huh? Anyone?
Yes.
Bueller? Good, Jared. I'm glad you know. What if I get an x value, and it's possible because we're using algebra here. What if we get an x value of, say, x equal, instead of 3, x equal -3? What happens there? It can happen algebraically, but in reality, it can't, right? Because there is no x value, any negative x value for with the log function. So when that happens, what do we have to say? Well, we have to say, hey, that's an extraneous solution, so there is no solution. And I bet you this example is going to happen too, right? What do you think? What do you think? All right, so what looks like my logs are isolated, right?
So you can divide by log
Divide by log.
on both sides, or is that just one on both?
Ooh. Well, I have to solve for x because it's an equation, right?
Yeah.
If I divide by log of x, that's still not going to help me out get that x out of the parentheses, is it? You know what I'm saying? If I divide by log of x, or which one do you want me to divide by?
Log of x.
Okay. So divide both sides by log of x, right? So these cancel out to 1 equals log 5x plus 6 over log of x. That didn't help me out too much, did it? Because I got to get x by itself. And the only way I get x by itself is I got to get rid of that log. Okay. I mean, it was a good idea, a good try. And that's the best thing for mathematics. Is just try something first. Try something. Unfortunately, it didn't work for this. I got to get rid of my log base 10. And the only way I know how to do that at this point is to exponentiate it. Remember, there's a base 10 there, right? So if I exponentiate it to and make it exponent of 10, they cancel. Now I can break that x out. So I get x equals, all of this canceled out. I get 5x plus 6. Now I can solve for x. Subtract 5x. I get minus 4x equals positive 6. Get x by itself, I'm going to have to divide both sides by negative 4. So x is going to equal, and I can reduce negative 6/4, right?
Negative 3/2.
Yep, good, Jared. However, my x can never equal a negative 1/2 because it's not part of my function. It's not in my domain. So guess what? This is an extraneous solution. Therefore, no solution. Something you're going to have to remember. Questions, comments, concerns? All right. You have 6 problems to do on your homework. Again, tomorrow is Delta Math Workday. Good day to make up any quizzes or other stuff you want to make up tomorrow, right? If you're missing a quiz, guess what you should do tonight? Study the review for the quiz and do it in class tomorrow. That way you won't have to. Actually, that's the last day before the quarter, so last chance you'll have to make it up before grade report cards.